Hey guys! Welcome back to the laboratory. In this video, we are looking at the fractional distillation of crude oil. By the end of this video, you should be able to define the terms hydrocarbon and crude oil, explain how the fractional distillation of crude oil works, and compare and explain the properties of the different fractions in crude oil. So, let's go! Crude oil is a finite natural resource formed from the remains of microscopic plants and animals that have been buried and subjected to high pressure and heat over millions of years. Crude oil is a complex mixture of different compounds, the majority of which are hydrocarbons, which, as the name suggests, are compounds containing hydrogen and carbon atoms only. In its natural form, crude oil is far too viscous and not ignited easily enough for it to be useful as a fuel. Instead, it must be separated into smaller, more useful mixtures called fractions, which is achieved using fractional distillation. Fractional distillation is a separation technique that is used to separate a mixture of substances with different boiling points. The technique separates the compounds in crude oil into smaller mixtures with similar boiling points. During this process, the crude oil is heated to a vapor and passed through into a fractional column. In the fractional column, there is a heat gradient. It is hottest at the bottom and coolest at the top. As the vapor rises up through the column, the different compounds in the mixture will condense as they reach a part of the fractional column that is below their boiling point. At this point, the vapor cools, condenses back into a liquid, and is piped away. The shorter-chained hydrocarbons with fewer chemical bonds will have much lower boiling points and will therefore condense near the top of the fractional column where it is coolest, whereas your longer-chained hydrocarbons with far more chemical bonds will have much higher boiling points and will therefore condense near the bottom of the fractional column where it is hottest. The hydrocarbons with very low boiling points do not condense at all. Instead, they leave from the top of the fractional column as a mixture of gases. Each fraction of crude oil contains a mixture of hydrocarbons that are of similar size and boiling points. Because of the different properties each fraction has a different use in the industry. We can use this table to compare the different properties of each fraction formed during the fractional distillation of crude oil. Fractions produced nearer the bottom of the column are much larger molecules and therefore contain more atoms, in comparison to the fractions produced nearer the top of the column, which are much smaller and therefore contain less atoms. It is this property that can be used to explain the trend in boiling points as you move from the bottom of the fractional column to the top. The fractions near the bottom of the column have much higher boiling points because they are larger molecules. This means they have more intramolecular forces that must be broken before they vaporize. In contrast, the fractions near the top of the column have much lower boiling points because they are smaller molecules, meaning they have less intramolecular forces that must be broken before they vaporize. Having higher boiling points makes longer-chained hydrocarbons less volatile. This explains why they are not as easy to ignite, in comparison to shorter-chained hydrocarbons which have lower boiling points and thus are more volatile. This makes shorter-chained hydrocarbons easier to ignite. The viscosity of a liquid is a measure of how easily it flows. A substance that has a high viscosity does not flow very easily, like syrup, whereas a substance with a low viscosity, like water, will flow much easier. The viscosity of the fractions decreases as you move towards the top of the fractional column. This property is directly linked to the size of the molecule. Longer-chained hydrocarbons have an increased number of forces within it, making it more resistant to flow. In contrast to your shorter-chained hydrocarbons, which have fewer forces acting within it, and therefore flow more freely. These different properties combined can be used to explain the various uses of each fraction in the industry. For example, bitumen is not used as a fuel because its boiling point is far too high and it is therefore not very flammable. However, its high viscosity makes it a great material in road construction. Fuel oil is used to heat homes, whereas diesel oil is used to fuel trains and vans. Kerosene is used as aircraft fuel because it is highly flammable and has a low viscosity, whereas petrol is used to fuel cars. The mixture of gases released at the top of the fractional column have the lowest viscosity and are the easiest to ignite, and are therefore very suitable for their use as fuels. Here's an example of a past paper question that I'd like for you to attempt to test your understanding of the content covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Crude oil is found in the Earth's crust. Use a word from below to complete each of the sentences about the fractional distillation of crude oil. This is a nice, easy 2-mark question. The correct sentences should read as follows. The separation of crude oil into fractions occurs in a fractional distillation column. Before the crude oil is passed into the column, it is heated. During the distillation, vapor rises up the column until it is cold enough for the vapor to form a liquid. The vapor has been condensed. The 2 marks here are awarded for placing the words heated and condensed in the correct spaces in the paragraph. And the second part of the question, complete this sentence by selecting the correct answer in the box. Compared with the fraction from the top of the column, the fraction from the bottom of the column, we can answer this question quite easily through process of elimination. We know that, moving up the column, the fractions become easier to ignite, and therefore the option is easier to ignite is not the correct answer here. Similarly, the viscosity of the fractions decreases as you move up the group, and so the option has a lower viscosity is also incorrect here. This of course leaves us with the correct answer, which is that the fraction at the bottom of the column will have more carbon atoms per molecule. And of course, to achieve the mark here, you would have needed to have selected this option as your answer. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon.